Hello everyone, I hope you are doing well this week. I wanted to do a couple of examples on the trig identities. That is something that you're going to be working on this week, and it's kind of like a little puzzle that you have to put together. And so I wanted to just take a few minutes and do a couple of examples for you. What I have in front of me is I have a proof, and the proof is already, the statements are already written out. What we have to show is we have to show on this side why each one of these statements are true. And so that's what we're doing here, is we're showing why 1 plus cotangent squared x times tangent x is the same thing as cosecant x times secant x. So that's what we're showing. So I want to kind of go through this with you and do a couple of these. Now, this right here is what I have in front of me and what I would encourage you to have in front of you. I've posted something similar in a couple of different places, and you can also get this through Alex when you kind of pull up some of these things to look at. We're really focusing on the reciprocal identities, the quotient identities, and the Pythagorean identities. Those are the three things that a lot of these proofs you're using to show the identities. So have this close. Now, eventually this will kind of become like second nature to you. You'll use some of these things in calculus for sure, but having it close by while you're working through your homework is really going to make a big difference. So let's look at this first problem right here. So we are going from this statement to this statement, and we have to talk about why. Why are we allowed to go from 1 plus cotangent squared x times tan x to the next statement? So we have to think about why that is true. So our tangent x stays the same. So we are looking at this right here and this right here. That's what we're looking at. So when I go over here to my sheet that has everything that I need, I see here that 1 plus cotangent squared x equals cosecant squared x. Okay, so that is why I am, sorry about that, that is why I am allowed to substitute these two things. It is this statement right here. So what I am going to put under the rule or the reason, I'm going to click on that, and it's going to give me a drop-down menu. And the one that I am going to pick is called Pythagorean identities. And the reason for that is because that rule is under the Pythagorean identities on my sheet right here. So now what we have to do is we have to look at, why do I go from cosecant squared? So this is what I'm looking at. Whoops, sorry about that. This is what I'm looking at now. I'm looking at cosecant squared x to 1 over sine squared x. So if I look at my rule, I see that cosecant theta is equal to 1 over sine theta. That is why I do the next step. So what I put here, because that is a reciprocal identity, the rule that I put right here is reciprocal identity. That's what I picked from the drop-down menu, reciprocal identity. Okay? Then, the next one, what I've done in this one is I have changed my tangent x. I have changed it to sine x and cosine x. And if I look over here, tangent is the same thing as sine theta over cosine theta. So this is what I am looking at for the next part. So it's like a puzzle. I am putting a puzzle together to go from this statement to this statement. And so I kind of have to see, and sometimes it's trial and error. Sometimes it doesn't always work out perfect. Or, well, it does work out, but sometimes whatever direction we're going, we have to back up and go a different direction. So this is our quotient. We drop that down from the drop-down menu, and it is our quotient identity, and that is what I use. And that's the drop-down menu that I would pick. Now, I'm still left with a sign on top. So if you look carefully at what I've got right here, okay, I have a sign on top right here, and I have a sign squared on the bottom. Now, if I've got something on the top and something on the bottom, I can cancel that out. So the sign X on the top gets rid of the sign squared. And so then I just have sign X. So I no longer have sign squared. So my sign X is still there, but my sign on the top cancels out, and I'm just left with 1. So from those steps, so from here to here, I have used algebra. That's just a property of algebra that I have used. Okay, and so I would write algebra. Now I have 1 over sine x and 1 over cosine x. And if I look at my reciprocals, 1 over sine x, where is 1 over sine? Here's 1 over sine x. That is cosecant theta. And then I have 1 over cosine theta, and that is secant theta. So these two right here, I am substituting in for that last part. And so the part that I'm using to go from this step to this step is my reciprocal properties, or my reciprocal identities. So what you're doing is you are using all of these identities right here. Some of them are algebra. We're also using algebra as well, to go through a process and to create a proof that tells us why we do each individual step. And this is how we show different identities. Okay? So again, what I would do is I would definitely have this close by. And I haven't done this in a long time. So this is, I'm teaching this class for the first time in a couple of years. And so I had to kind of go back and look at my identities again. So definitely keep this close by. I would print it out. I would print out some of those different things that I've given you along the way. So now we're going to do another one. Okay? Here, we've got to do the whole thing here. So we've got to look at this one carefully. So what I've got here is I've got cosine x squared minus sine x squared, or sine squared of x. What that means is, when I've got cosine squared of x and sine squared of x, I'm really saying that's the cosine of x squared. But we write it that way because if I just write it cosine x squared, it looks like just the x is being squared, and that is not what we want. We don't want that. So that is why it has been written as cosine squared of x. But it means the same thing as you are squaring this entire quantity. The cosine x is squared, but that's how it's written. But it carries on all the properties that a square carries from our algebra time. So we are going to complete this proof. So we're doing the proofs and we're doing the rules that justify each thing. And inside Alex, you'll be able to kind of type up your step, and then you'll have a drop-down menu that says why you're allowed to do it. So I want us to look at this right here. So I want us to look at cosine squared of x minus sine squared of x. And if we look back on this page and we look down right here, I have sine squared of theta plus cosine squared of theta equals 1. Now I'm going to take this. So I've got sine squared of theta plus cosine squared of theta equals 1. I am going to solve this for cosine. And the reason I'm choosing cosine, let's look at what this is asking for. I'm choosing cosine because I need to get another cosine over here. I need to go from cosine squared x minus sine squared x to 2 cosine squared x minus 1. I want to go from this statement to this statement. That's what I'm proving. So I need to get rid of a sine squared of x, and I need to get another cosine squared in there. So that's why I'm solving this for sine squared. So I am going to subtract cosine squared from both sides. So I will end up with sine squared of theta equals 1 minus cosine squared of theta. Okay, so I just subtracted that. I took this identity right here and rewrote it. So what I'm going to do now is I am going to take this right here, 1 minus cosine squared of theta, and I am going to put it in for this sign right here. Now, on my identities page, I have theta, but here I have x. So I am going to have cosine squared x minus, now instead of writing sine squared x, I'm going to write what I solved for over here. So I have 1 minus cosine squared of x. Okay, and that equals, and what I'm trying to get it to equal is 2 cosine squared x minus 1. Now, I've got to give a reason. I've got to give a rule. And the rule that I use to do this is a Pythagorean identity. So the rule, the justification that I'm going to write down is Pythagorean identity. And if you pull up the rule list, it'll give you Pythagorean identity as an option. Okay? Now, the next thing that I'm going to do is I'm going to use algebra. I'm going to distribute this negative. Okay? I'm just going to use algebra. Okay? So when I do that, I'm going to have cosine squared of x minus 1 plus cosine squared of x. Then, because of that, I've got a cosine squared of x here and a cosine squared of x here. Those are like terms. So I can turn that into 2 cosine squared of x minus 1. And both of these steps right here are algebra. That's what we did. Right here was algebra. Okay? And now I have gotten to what I needed to get to, which is 2 cosine squared x minus 1. So this is my answer right here, and I have proven this identity. Okay, let's do another one. So here I have complete the proof of the identity by choosing the rule that justifies each step. So again, we are wanting to go from this statement to this statement. Okay, I always start on the left, but you could always go on the right back to the left, but you have to justify each step. We're proving what's happening here. So we are going to keep this very close. We've got to kind of go back and forth and look at this and see what's happening. So I'm going to look here first. I have 1 minus cosine squared of x times secant x equals sine of x times tangent of x. So that's where I want to go. So I want to focus on this part right here, 1 minus cosine squared of x. 1 minus cosine squared of x. Now, if I go back to here, I'm going to focus on this again. I can solve it, and we already did this once. Sine squared of theta is the same thing as 1 minus cosine squared of theta. Okay, I already knew that. We already did that once, so I'm going to do that again. So I've got my 1 minus cosine squared of theta. I am going to take that out, and I am going to put sine squared of x times secant of x. Okay, and the reason that I'm allowed to do that, the rule that I'm following is a Pythagorean identity. Okay, that is the Pythagorean identity is one of the reasons that I'm allowed to do that. Okay, now secant of x is the same thing as 1 over cosine of x. Okay, and I know here we've got theta, but in our identity, our angle is labeled x, so that's how we're able to change that. Theta just means any given angle. So my next statement is going to be sine squared of x times 1 over cosine of x. And the reason that I'm allowed to do that is because of my reciprocal identities. And really, this is just kind of playing a little bit. We're guessing and we're checking. We're using this table right here to see what's equal and what's not equal and what I can switch out to prove that these identities work. Okay, so that's my reciprocal identity. Now, this sine squared of x, I could rewrite that as sine of x times sine of x. And then I can have cosine of x. So all I've done is I've taken this sine squared of x and I've split it to sine x times sine x. And that property, or that rule that we're using, that's just algebra right there. And sometimes in trig, where we get stuck is our algebra. But just hang in there with your algebra. Now, if we go back to this rule right here, or this group, I see that when I have sine of theta over cosine of theta, that is tangent of theta. So I can take my sine of x and my cosine of x, and I can turn that into a tangent x. And that is my quotient identities. And that is the reason that I do those. Quotient identity. Okay, so we're doing proofs. We are walking through the steps. We are using our identities to move from one statement to another statement. And it takes a little bit of time, and we have to, it's a little bit of trial and error. But the key is having this in front of you. This right here is going to make all the difference. Okay? Let me know if you have any other questions. I'm happy to help.